Okay, so today we're going to talk about graphing a line using intercepts. So we talked about one intercept already. Right, it's a little bit of review we had the last one. The y-intercept is the y-coordinate of the point where a line crosses the y-axis. Okay, at this point, the value of x is equal to 0. Okay, so before we actually discuss this, what were some of the two ways that we've learned in how to graph a line already in this class? The two methods that we sort of did. Anybody recall what those two methods were? One of the two? Eric? Yeah, so we found in this case the y-intercept, it could be actually any point on the line, right? But in this case we targeted the y-intercept, and then from there we used the slope, right? So we took the point and then did slope, rise and run, get to our next point, and rise and run again to the next point, and then we got a sequence of dots that we just connected with a straight line. What was the other way? It's kind of trivial. I know you might even think of it as a way, but we did this way back. Even when we first introduced this lesson with the computer program. Not 2 points. Well, not quite 2 points. We did more than 2 points, but you're right. How did we get those 2 points? What did I make you guys draw? Yeah, table. We did a table of values, right? We had input x, and then output is y, right? And then you did plug in x, and then you got the associated value for y, and then you did your plots, right? Veronica? So today we're going to talk about a third way you can actually draw or graph a linear relation. Okay, so we talked a bit about the y-intercept. There's another intercept that the line, line can pass through. What do you think that one might be? X-intercept. What does that mean though? What does crossing the x-intercept mean? When a line crosses through the x-axis, right? So instead of here, we talk about the y-intercept which is crossing the y-axis. A line can also pass through the x-axis, right? What do you think is special with that point? Where y is equal to 0, exactly. So the x-intercept is the x-coordinate of the point when a line crosses the x-axis. And here what we'll notice is that y is equal to 0 at this point. Okay, so we'll go through some examples. Okay, everybody done with this? Good question. Okay. So here we have a relation, 3x minus y plus 6. How do we know that this is a linear relation? How do we know that it's a linear relation to begin with? Yeah, we could turn out to slope intercept form. But what exactly are we looking at in particular? What variable here? The x, right? Also the y. What's the exponent of both of them? It's just 1. Okay, so this is how we know we have a linear relationship. We have two variables, exponent of both is just 1. So how do we go about finding the y-intercepts since we're more familiar with that? How do we determine the y-intercept? Well, not quite isolate for y. What do we want to do first though, maybe? I mean, what's special about that y-intercept again? So remember, look back in your notes. What's special about that y-intercept? What do we know about that value? A certain value there. In general. Right, we just wrote down the definition of a y-intercept. What's special about it? Yeah, at that point, x equals 0. Right? So in other words, at the y-intercept, we have x is equal to 0. So what's the value of y when x is equal to 0? I don't know. Let's work it out. So 3 times 0 minus y plus 6 is equal to 0. In other words, we're just plugging in x equals 0 to our equation. It's like our independent value. Now we want to find the result. Right? So what's the value of y here? Well, 3 times 0, as Matt said, is 0 minus y plus 6 is equal to 0. So now we want to isolate for y, right? So here I want to add y to both sides. So minus y plus 6 is equal to y. So 6 is equal to y. So when x is 0, y is 6. So what point does that give us? Okay, but what's the coordinates? 0, 6. The coordinates always have the x and y pair. So therefore it's 0, 6. So we'll go off to our graph and we'll plot 0, 6. Well, how about the x-intercept? How could we calculate the x-intercept? Right? Yeah, at the x-intercept, basically where it's crossing our x-axis here, the value of y is equal to 0. Here's y is equal to 0. So we do the same thing, except now we're plugging in y is equal to 0. So 3x minus 0 plus 6 is equal to 0. Now we go off and solve for x. So here I get 3x plus 6 is equal to 0. Subtract 6 on both sides. So 3x is equal to negative 6. Divide both sides by 3. So x is equal to negative 2. Okay? So basically we found out what the value of x is when y is 0. So what does that give us now? Our x-intercept, so what's the point? What's the coordinates? Right? So when x is negative 2, we know that y is equal to 0. You can easily check that by plugging in x equals negative 2 in our equation over here. Right? So 3 times negative 2 is negative 6 minus y plus 6, which equals negative y plus 0. So y is equal to 0 in that case. So we know that it works. So we'll plot the other point right here. Negative 2, 0. And then we'll do a straight line through it. So with your ruler, I'll do this with this. Right, we're going to make a straight line. put arrowheads on there. Okay. So that's how you could graph a relation now by just using the intercepts. Any questions on this? So you can try this one. You guys can try this one on your own. Because as I'm walking around, a lot of you are doing a good job just labeling what you're doing first. So I see a lot of steps saying y-intercept, this is what I'm doing, and x-intercept, this is what I'm doing. Did I call? Go for it.
Do the X one as well.
Yeah, do that whole thing. Label what?
See how you have lines that
Yeah. Very clear. Right.
X like right
Why does that mean y dash?
Y is what I do.
Yeah. I wonder why you do things the way you do often as well. What we're working on there is your communications. Okay, I can do this straight line. All right. Thank you. So algebraically, what Colin did was correct. So we got the y-intercept of y is equal to 5. What I'd like to see here is that therefore, just put your coordinates. So 0, 5, right, when x is 0, and here we got 3, 0, right? That's your x-intercept. And then you go back in your graph and you label it as well. So here we got 0, 5, and 3, 0. Okay, it's kind of important to label the points, especially when you get answers that aren't exact, right? So let's say that we got our x-intercept is actually 3.1, 0, right? And I could put it right there, but it's hard to exactly put 3.1. But if you actually label it and it's clear to whoever's looking at it, that's where the x-intercept is. Okay, and then in the end, we draw a line through this. Here to here. Okay. Clear? Any questions? Okay, so actually this is a pretty easy concept of graphing through the intercepts, right? Setting y is equal to 0 to get our x-intercept, and setting x equals 0 to get a y-intercept. Getting those 2 points, because once you have 2 points, you could draw a straight line. Okay? So let's look at it a little bit differently. And so, well, how can we get an equation of a line given that we're just told the intercepts? Okay, so here in A, which is, well, the x-intercept is -6, the y-intercept is 4. How can we get the equation of a line? The first thing we want to do is sort of approach this, well, how do we get the slope? How can we get the slope from here? I mean, we're only given like the x-intercept, the y-intercept, -6, 4. Does it seem like there's a lot of information? Tyler?
y2 minus y1 over x2.
Okay, so we have an equation for a slope. So I'm going to preface this first with what you said, right? We're going to do delta y over delta x first. So that's what we have is y2 minus y1 over x2 minus x1, right? Need to memorize the slope equation, slope formula. But I'm only given 2 numbers. How do I calculate the slope from that? How?
You use like the points in the basically y-intercept, so like it'd be like 0, -6, 0, like 1, -6.
Okay, so our x-intercept, right, implies what?
That x equals 0.
The x-intercept is where it's crossing the x-axis.
And
Right.
the y equals 0.
So we could say that the x-intercept is 0.1. So what'd you say the x-intercept is? What's the point of that? The x-intercept is -6. So what's the actual point there?
Oh wait, no. The x, yeah, the x-intercept is -6 and
Right.
comma 0.
That's right. So remember, the x-intercept means that y is 0, right? Where the x-intercept is, that's the value of the x. So that's the first point.
0.
So our second point for the y-intercept, right, we can say that's 0.2. Well, what's the coordinates of that point? That 0, 4, because the value of x is 0 in that case, and y is 4, right? So now I got my x2, y2, and x1, y1. Okay? Write this out. Write out your 2 points, put x1, y1 underneath x2, y2. This way you won't get confused when you calculate the slope. They have to be in that order. y2 minus y1, x2 minus x1. That's all.
Can't you just take the two coordinates and find and use the y as rise and x as 1 and just do 4 over -6?
So you're saying that the delta y is 4,
Or no, you see how it's the y-intercept and the x-intercept?
right?
That's 4 and -6. Can you just do like 4 over -6?
I would probably prefer this way because you might get your signs mixed up.
Wouldn't that make it like a lot simpler because you don't have to like, because it's just 2 numbers instead of 4? Like, technically.
Did you really have to do this?
I'm thinking if the signs is going to work out or not, depending on x and y-intercept. Let's work it out here. Okay, now let's see if we could get that shortcut or not. So it's y2 in this case is 4 minus 0 all over
-6 minus 0. So it comes up to the same thing.
No, it'd be
Yeah,
0
0
minus negative.
yes. This is why we need to be careful. So we got x2 is 0 minus a -6. See, I think this is the catch because one of them is flipped. And that's what I'm trying to work in my head over there. Right? Whether the signs actually work out. So we got to make sure that we got y2, which is 4, minus y1. But then on the denominator, we got to make sure we got x2, which is 0, minus a -4. And here we got 4 over 6, which is just 2/3. So the only caveat I would make with that to what you said, Colin, if you want to remember a shortcut, is you can do that and you need to flip the sign.
Alright.
Okay? I don't like rules because it's harder to understand. I like to work things out. Because if I forget the rule or if I mess up the rule, then I got the wrong answer. Whereas I can always go back in algebraically and get the correct answer. I don't like math. To me is not about rules and regulations. Not about memorizing stuff, but it's about working it out. So now I got the slope. How's that help me with the equation on the line? Well, I got y is equal to. So here I got 2/3 is my slope. So 2/3 x. What's my y-intercept? 4. Give it to us in this case. So it's 4. Okay, so that's how we get an equation of the line algebraically. Okay. Second one's a little bit harder. You want to try that on your own or work through it together since it's got a fraction in there?
Let's work through it together.
Work it together?
That's thrown off by that fraction.
Yeah.
Nothing wrong with that.
Throwing me off.
So let's go with, because we're given 2 points, let's explicitly state what those points are. So here is my point 1. What is that? What's the value, what's the point of my x-intercept? What's the actual coordinates?
1.
What's the actual coordinates of my x-intercept?
0.
8 over 3 comma 0, right? Because that's just my x value. What about my y-intercept? So here x is 0 and y is -2. Okay, so to do the same thing, we need to choose this as my x1, y1, x2, y2. Just make sure we explicitly label it, so we don't get confused. So here my slope is delta y over delta x. y2 minus y1 over x2 minus x1. So here, y2 is -2 minus 0. And x2 is 0 minus 8 over 3. So -2 minus 0 gives me -2. 0 minus -8/3 gives me -8 over 3. Ooh, now we're dealing with fractions.
How do you get?
we get 1.
No, I was wondering how we got negative.
Because, 0 minus the 8/3, so we got negative 8/3. Yes, Aaron?
Oh, I'm sorry.
Sure.
When I did negative 2 times.
Yeah, so we can multiply the reciprocal, right? Because we divide by a fraction, we just multiply the reciprocal, which is minus 3 over 8.
And I have 3.
So this is equal to, and my negatives cancel, so it's 3/4. When we're dividing by a fraction, we multiply by the reciprocal. So reciprocal of 8 over 3 is 3 over 8. Negative times a negative is so we know our answer is positive. And here reduced by 2, both numerator and denominator, that's how we got 4 in the bottom. So we have 3/4. So here my equation is y is equal to 3/4 x. My y-intercept is, right? So I get asked this a few times already. Can my b value be negative? Because we always go y is equal to mx plus b. Well, b can be a negative value, right? So here we got 3/4 x plus negative 2. We want to leave it like this though. No, that's not proper math notation, right? We're going to do a plus negative, so we just change that to y is equal to 3/4 x minus 2. Okay. Do you need this step? No, you don't. I just want to emphasize that b can be a negative value there. That's how you actually see it. Okay. Questions on this one? Okay, so I want to go through this next example pretty quickly. It's kind of confusing. So Jacqueline goes to a hockey game. Can't be a Leafs game because you can't get Leafs tickets. So it must be like a Marlies game or something. $20 to spend on hamburger and some pop.
We have a different. We have baseball. Oh no, we have.
Yeah, I know. I changed it on this because I'm not a fan of baseball. I like hockey. Right. You can always get a baseball ticket. Well, I guess this summer it might be hard to get because we actually got a pretty decent team. So how can we write an equation for to model this? So the idea is that she wants to spend all $20 because they're like my kids. There's no such thing as returning change to me, right? Give them $20, it's like, oh, I get to spend the whole $20. Not coming back with $10 or $5 or anything, right? So here the idea is that she's spending the entire $20. So we want to sort of figure out, come up with the equation to model what she can buy with this $20. Her and her sister, right?
No burgers, $10.
Yo, I was thirsty.
That is possible. But how can we come up with an equation to model this though? Well, that's first thing we want to do is just think on some variables. Okay.
Pop could be P.
So give me a variable for hamburgers. H. So let H equals number of hamburgers. Now how about for pop? P. So let P. Let P is equal to number of pops. So what's the equation you think that we could come up with? Determine number of pops, number of hamburgers that Jacqueline and Nicole can buy. Call it.
4H plus 2P equals 20.
4H plus 2P is equal to 20.
Yes.
How'd you come up with that?
Because it's $4 times the number of hamburgers plus $2 times the number of pops is equal to $20 because that's all she has to spend.
Yeah. Right. So just just take a number of hamburgers right? So H represents the number of hamburgers. Well, in order to calculate the cost of the hamburgers is when you multiply 4, because each costs $4, times H. And you do likewise with the pop. Each pop costs $2. So how much you spent on pop would cost 2 times the number of pops that you bought, which is a variable P. So this is one abstraction that's kind of a little bit difficult in grade 9, that we're no longer thinking about numbers, right? Think about P as the number of pops. Whenever we think about number of pops, we don't think of an actual number, we think of a variable. Same thing with the number of hamburgers. Instead of thinking of a number, now we represent that with a variable. So now we have this equation. So now how can we answer the next question? Jacqueline buys only hamburgers, how many can she buy? How can we sort of solve that? I know you probably do in your head, but how can we solve that algebraically? Matt?
20 divided by 4.
Okay, how do you get in there though?
It's like $20.
Right?
Each hamburger costs $4.
But what are you assuming though?
That's just
How many pops does she buy?
she buys 20. She buys 0.
No, she's only buying hamburgers.
Yeah, so she buys 0 pops.
So here we're saying that P is equal to 0. Okay? So here we're saying that P is equal to 0, so we plug that into our equation. We got 4H plus 0P is equal to 20. So now we're left with 4H is equal to 20. Divide both sides by 4. Now we get H is equal to 5. So that's basically what you said, Matt.
Yeah.
We just need to have that concept of, well, really P is 0. Really P 0 is into our equation. And that's how we could actually figure out the number of hamburgers. So likewise, if she only buys pop, Matt gave his answer already when we asked it. Right? So we're doing something the opposite. So here, H is equal to 0. So therefore, 0H plus 2P is equal to 20. Well, here it's just left with 2P is equal to 20. Divide both sides by 2. And left with P is equal to 10. So therefore, $10.
Who would want to buy 10 cans of pop?
Okay.
Oh, so thirsty.
You can't jump.
Yes, you can.
It hurts.
No one, no, it doesn't.
Don't get it filled up that.
No one says you have to drink it all at once.
Chugging, that's what chugging
It
means.
hurts when you
You don't have to buy it all at once.
She's selling it for $2.50 and getting
Hey,
some money.
hockey game's a long time, especially goes in overtime, right? Okay, can I remember your therefore statements? Right? I took a shortcut, I said 5 hamburgers, we want complete sentences. Right? Therefore, she can buy 5 hamburgers. Therefore, she can buy 10 pops. Okay, just want to kind of get through this. So we want to graph this. How can we kind of do that? How can we kind of graph this?
Oh my God, this is
How can we kind of graph this? How can we just take what we learned, previous examples, how can we graph this? Think about it. Think about it. How can we graph this then? How can we graph this? Well, what goes along our axes? Sorry? Our variables, right? So we have independent along the horizontal, dependent on the vertical. In this case, which is our independent, which is our dependent?
Independent is like independent. Yeah. It's food.
Well, we have 2 variables, right? Hot dog, hamburgers, and pops. Which of those variables is our independent variable? You can argue for either case, right? The number of pops I buy affects the number of hamburgers I can buy. Sure.
Yeah.
If I buy 5 pops, doesn't that affect the number of hamburgers I can buy? Well, again, so you can also think of it the other way, right? The number of hamburgers I buy affects the number of pops. Okay? So in this case, you can argue either way. Just put 1 across the x-axis, 1 across the y. You guys call it.
Oh, I have. Oh crap! I'm not sure how to learn this. Oh, I can see the relationship between what we were learning before and this.
Are you?
Yeah.
Good.
Can I say it?
Well, which one you want across the x-axis?
Pops.
Pops?
You'll get full from pop. And
No, pops is carbohydrates.
Pop makes you
I can't finish it.
so.
I must just
Okay, so we have number of pops across the x-axis, or horizontal axis, number of hamburgers across the y, vertical. So Colin wants to tie this in for us.
So you know how when we were saying that like when we're at the y-intercept, x is always equal to 0? Because we have 5 hamburgers and 0 pops, the y-intercept for the hamburgers has to be 5, because at that point, pops, aka the x-axis, is equal to 0.
Okay, so let me label this first. So roll 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So same scale here, 2, 3, 4, 5, 6, 7, 8, 9. So what is it that you're trying to say, Colin?
Because okay, so our number of hamburgers is the y-axis, and the y-intercept has to be 5, because when the y-intercept is 5, x has to be 0.
Well, okay, well, how about we refer back to this example?
Oh,
When we have 0 pops,
we have to have 5 hamburgers.
we're gonna buy 5 hamburgers, right? So that's how we kind of plot that, right? We have 0 pops, which is why we sort of asked that third question. Sorry, the second question. You have 0 pops, you're going to buy 5 hamburgers. Well, conversely, Colin.
If she has 10 pops, she can only buy 0 hamburgers.
Yeah. So conversely, if she buys 10 pops, she'll get 0 hamburgers. So first of all, we know this is a linear relationship because we have 2 variables. The exponent of both variables is just 1. So it's a linear relationship, and we plotted 2 points, or intercept in this case. Right? When one of the variables is equal to 0, what's the value of the other variable? And now we could draw a line through here. Exactly like that. So now what we can do is, you can say that, well, if she bought 1 pop, how many hamburgers can she buy? 4.5 hamburgers.
Ooh, yeah, half. McDonald's are like half of McDonald's.
So that's why I'm not crazy about this example, because we can't get it to halves. It really should be a scatter plot.
You do like slices of pizza.
Right? But we can see easily that she bought 2 pops. She's going to buy 4 hamburgers. Okay? So for homework, we got some questions from the textbook. Finish that off, please.